Hi, I'm Damien from DK Engineering and Machining. So a few months ago we had the big task of moving workshop. So today we're going to do a bit of a shop tour and show you what way we are operating now. So we're still probably about 3/4 way through the setup phase. So there's still a lot of stuff to do at the shop, but I want to give you a preview of what it looks now and how we're operating. So come on in. So before we start, here's a quick look at what the shop looked like when we took it over. So you can see it's just had a brand new epoxy floor, a new roof, insulated roof was installed, all painted fresh, ready to go. There's quite a bit of electrical supply in the shop, so there's about 250 amps, which is sort of very pivotal for our business, not having to upgrade the power. So this is on moving day. We had Scott's Transport come in and basically shift all the machines and all the gear from our old shop over. Pretty much one day done the full move. So here we can see our MCV coming in through the door, and this is the first time that we've actually had a big enough warehouse where we can drive the forklifts in with the machines straight on, not have to escape them. Unfortunately, halfway through the day we got probably one of the largest recorded hailstorms in our area for probably 20 years, but luckily the guys were able to drive the trucks in and offload while that storm was happening, so which was pretty lucky. We could have had a lot of damage there, but we got away with it. So this is our front office area, reception area. So at the minute we've got Candice lives here. That's my desk there where we do all our programming and quoting and general administration stuff. We do have 2 more additional offices upstairs that we go through afterwards. Yeah, so right, we'll go into the workshop now. So the workshop is 250 square meters, including the offices. So out here we've got some pallet racking. This is like our dispatch and material sort of job storing area. So we've got some general stillage racks there that we keep our raw stock in. We've got a dispatch area there where we organise all our dispatches. We've got a storage bay here where all our finished jobs get packed and couriers and stuff go to pick up. At the minute it's pretty rough and ready. We've got a few plans in the works to develop some standardized storage racks for all our stock standard round bar for our turning centers, and a lot of this stuff will get dissolved up into new storage upstairs that we've just built, which I'll go through in a few minutes. So that's pretty much the main entry with our storage and our important barbecue. So we do a barbecue once a month on a Friday. So yeah, so we go down, we go into our manual sort of machining area. So we've just got our standard horizontal bandsaw. We've got a 30-ton press there. We've got a slotting machine which we have purchased recently, which we are about to set up on a job. So this will do internal keyways. We do a lot of big drive sprockets and idle sprockets for abattoirs, which require big keyways, and we were previously sending them out, or we were broach cutting them in the lathe, but this is I think a more stable and a more machine friendly solution to do keyways pretty efficiently. And then we've got our universal mill. So I don't know, we done a video before for practical machinists, and we sort of went through a bit of a description of this machine. So it's a global universal mill. We actually bought it damaged, and it fell over. It was a friend of ours that had purchased it, and they had a mishap when they were installing. So we had a cracked casting, we had some broken lead screws, and we basically repaired it, put new parts on as were needed, and got it back to life. So it's awesome. It's got a pneumatic tool changer, good DRO. It's got power feed and all axes, so it was a nice upgrade from our previous one, and gets used pretty regular. We're not doing as much breakdown and job shop stuff as we used to, but it's still a very important machine for the shop. as is our manual lathe. So it's just a standard manual lathe, probably a meter or 1100 between centers, 56 spindle bore. Again, gets used for small batch stuff, any quick skims we need to do on material to get into the machines, into the CNC machines, any small adapters or anything. We're a big believer that no matter how many CNC machines you have, you still always need your manual machines. You still always need them to get you out of trouble. If you've got a breakdown, you still need the ability to be able to jump onto a manual machine and cut. And also, anyone that comes in, we're also a firm believer that they should be able to run manual machines before they even step near a CNC. They should understand sort of how the machine should react, what they can do, what they can't do before they just hit the go button on a CNC. So that's pretty much our manual machine inside. Over here we jump into our CNC side. So you can see we've got it sort of segregated. Manual machines over here, CNCs under here. This here is a sort of part of our dispatch area, which is going to get absorbed into there when we do develop it. So just all our packaging, our tapes, our scissors, all that sort of stuff, all our boxes. Trying to standardize how we do things. We're a very lean, proactive lean shop. So we're always looking for those little improvements, how we can make little jigs and fixtures to keep everything organized so everyone knows it has a place, like a simple little fixture, a timber fixture to store our different size boxes. Chris, our ops manager, whacked that up in about 45 minutes, and then it's got a label on it so everyone knows, all right, there's where the boxes live. And it's just simple things like that we try to roll out incrementally through the shop. Not do everything at once, but just small continuous improvements, and day after day the shop gets better. So in here we've got our Harrison Alpha 550S. It's tucked away in a little corner here. So this machine we bought, we actually bought two of these machines about 6 months ago, and we bought them out of auction. We were looking for a solution. We've actually been looking for a semi-automatic machine for quite a while. I used to operate a smaller one back in Ireland, and I find that they're just a very versatile machine and a nice step up from the manual machine, especially if you've got new people coming on that have manual machining background but don't have CNC. This is a nice integration. It's not super CNC heavy, super G-code heavy. You can get a machine like this up and running pretty quickly with very little knowledge, and it services a lot of our bigger work. So it's got a 4-inch spindle bore, about 2 meters between centers, and we can swing about 750 with the bed out. And we do quite a lot of large sprockets where we just need to do some internal work, and this services that work quite easily. So yeah, it's been a pretty good machine. It's had a fair bit of work on it, but it's still very useful. And yeah, we've probably ran it for the last maybe 6 months. So that's our semi-automatic Harrison lathe. We move down here and we go into our more CNC section. So anyone that knows us, we had our first CNC lathe was a Hitachi Seiki. Then we bought a Sile X7 CNC mill with a 4-axis, and we had the Sile for probably about 2 years. The Hitachi, we probably ran it for about 10 months, and as we started to grow that turning side, we quickly sort of ran out of capacity, and that led us to go down the route of more automation stuff. So we jumped on and made the big decision to go for a sub-spindle lathe, and as we sort of scoped out the market, we came across the SMEC machines, and that's how we sort of got involved with SMEC. So you'll see here, like, we are quite a SMEC heavy shop, and there's numerous reasons for that. One of them being the service we get is amazing, and it's local, so that's a big driver for us, and the machines are top end as well. So The latest one we've got here is our SMEC SL3000 LM. So this machine, so you can see new model SL3000. We got this machine really to take over the work from the Harrison, and it'll still have its purpose, but this was mainly to take over the bigger work and to take the bigger work off our sub-spindle lathe, which we'll show you in a few minutes. So this is a C-axis machine. It's got a 91mm spindle bore. It's got a meter between centers, and we've put a good few extras onto it as well. So we've gone with a Sam Chully JB chuck. We've gone with an EWS quick change system. We've got an auto door coming on it, and that is sort of forecasting down the line where we want to be lean, we want to be more automated. We made the decision to go with an auto door from the start, so if you do want to add any sort of automation, whether it be a robot like a cobot or a robot gantry, or not pallet pool, but a palletized robot gantry, we've got the facility. The auto door is already there, so we can integrate that quite easily. So that sort of automation is always on our mind for future, and it's a small additional expense to add into the initial purchase of a machine to sort of to protect you down the line if you do want to go that route. So yeah, this is our biggest machine. We've got quite a long bit of travel. We've got about 650 swing in there, 91 spindle bore, bigger, more rigid machine, 12-inch chuck. So all of our bigger billet work, like you can see here, that's getting chucked into there. Any of our shaft work, all gets chucked into there. We run it just C-axis, doesn't have Y-axis, but it basically services that bigger stock standard sort of stuff. Tail stock as well, so any of the longer stuff is a bit easier. And then our quick change EWS system, which I think I'll do another in-depth video on that down the line, and I'll do another one on the JB chuck. But basically this allows us to, it's kind of like a Capto system, and we have tools already set up in sort of their own holders, and they just get swapped in and out, so we can quickly swap our drive tools between each other. It's got a FANUC OITF plus interface, and at the minute it's not on the network, but like the other machines we'll hook it up to the network, so if we do want to do any semi-complex cam stuff, we can program it and then send it directly across. But yes, that's our latest machine, which is the SMEC SL3000. And now there is our fabrication table. That we don't do a lot of fabrication anymore. We were quite heavy on the fabrication side, and then we made the realization a few years ago that there was it was more scalable and more beneficial to focus on the CNC side. Staff is a massive issue all across the world now, getting good quality staff to work. So we feel like we should put more effort into the automation of the CNC machines, let them do the work. So now we don't do as much fabrication, it's more support to the CNCs. If we do need to do any mods, or if there's machine parts that need welding and then post machining, we offer that, but pretty much just as a support to the CNC side. So coming into here, we got our main cell, which is our sub-spindle lathe and our 4-axis mill. So this one here is our SL2000, again a SMEC machine. So this is a sub-spindle Y-axis lathe, 68mm spindle bore on the main, 8-inch chuck, 6-inch chuck on the sub. Y-axis, we got about 110mm travel on the Y. We've got about 550 between centers, and we do a lot of bar fed work, and we try to always do one and done where we can. So we put a lot of effort into a lot of parameter driven programs, and we try to transfer everything. So even if it's just a bush that has a face and a chamfer on the backside, we'll try and transfer that so it comes out one and done, so there's no operations, gets clean, put in a box, and it's ready to go. Again, trying to let the machines do as much work as possible and freeing up our people to do more crucial and more critical work. So this is like a stock standard component that we're just after running some variants of. So they're hydraulic couplings to go into welded assemblies. These ones actually have a dry seal, an NPTF dry seal threads. We had to get some gauges from the States to do that job. But that's a typical component that we will do on this machine. We'll machine it out here, do all the internal work, screw cutting, we'll transfer it, do it on the back side, comes out one and done into a box and go. And typically this machine will be running quantities of probably minimum 50 up to thousands, depending on the order. At the back we have so we got an LLS bar feeder that we load in bars at just over a meter on that. So we typically will load up and run this during the day and then run overnight unattended. We utilize the two load monitoring in the controller as well as counters and stuff like that. And we're constantly trying to develop that unattended lights out machining stability so that we can confidently turn it on, walk away and know that the machine is going to be comfortable, and if it does have a problem that it's going to stop itself before doing damage. So two load monitoring has been a big help for us to confidently walk away from the machine. And as I said, like, this machine has been our sort of like our workhorse for maybe 2.5 years, coming up to 3 years in November. But we have been doing everything on that, from 620 diameter sprockets down to bar fed work, to prototype work, to hydraulic work, billet transfer, all that sort of stuff. So a main reason for getting the bigger machine was that it could take off that smaller batch quantity and larger diameter work onto a bigger machine that's not as complex a setup, and keep this one running one and done sub-spindle transfer work as much as possible. Behind you here we have our MCV 5700L milling machine. So this one here is about this one will be 2 years 2 years this November. So it's again a SMEC, it's a long bed. So we've got 1.6 travel on the X, we've got 570 mil on the Y, we've got a 250 diameter 4-axis, which we have made adapter plates and pushed off to lifted and pushed off the side to give it as much operating room as possible. We've also, you can't really see it here now, but we've made our own sub plates with 0 points on them. So we have underneath there, we've got 8 0 points, and that allows us, so these are our own fixture plates here that we've made that just allow general fixturing and pull through operations. So they've got 0 point on them, they drop straight in. We've got an array of vices and chucks down below, and they all have their 0 point system. So they just drop in straight away, no tramming of the machine or of the vices into the machine. We also run some trunnion work as well. So a lot of the time, if we're doing some complicated work, we might have a vice on the table, or else in the trunnion, it might do some work there. It might go into the straight up off the 0 point, part stays in the vice, goes into the 4-axis, does some rotary work, then it might come out of that, we might put it into the trunnion, and then we do some work that way, and then we can actually rotate 90 degrees, put it in, and then do work on the other axis. So having that flexibility of being able to move a vise through to different orientations, but maintain that that accuracy of the job in the vise, that's been quite a big game changer for us, and it's allowed us to do some pretty much 5-axis jobs on 4-axis machines. We recently put a back plate on, so we were getting a lot more small aluminium work, some plate work, some stuff that's just a little bit harder to come across the top and clamp. It's doable, but it's just very time heavy, so we invested in a vacuum fixture or vacuum plate to quickly do larger quantity stuff on thinner sheet metal parts. And yes, that's pretty much our MCV 5700L milling machine. And you can probably see here we've got two towers here with some tool tags on them. We're just in the process of rolling out a whole new tool library, so we were limited to 100 tools in the controller, and we got that bumped up to 400. So we're still sort of running half and half in that old tool library, and we're about to just roll out a new one, so these will all get their individual labels. So the concept is these here, I'm sure you are all familiar with tool tag systems, but these here are all your tools that are in the machine, so quickly you can look and see what's in the machine. We'll pick up tool. So on our rack we have our standard tool rack there with all our other tools. On our label, I don't know if you can see that there, so it's a standardized tool library. Every tool gets a number, gets an offset, so tool 17 will be offset 17, 18, 18, 19, 19, and that'll be, this one here is assigned to an 8.5 drill. So tool 17 will always be that drill. When we want to put that into the machine, we take the tool tag off, we swap out another tool, we put that in, we take the other one off, we put the tool tag on it, and we put it back in the rack. The beauty of this is that we don't break down tools. If we need a different tool, it gets a new tool holder and a new tool number, and then that standardized tool list just gets populated. So every time I put in tool 17, I don't have to tool set it, I just go and it should have the same offset that it's always had, with the caveat that if you break a tool or move it, you just got to update it, and also that it matches what's in your cam system. So in our cam system, we run Fusion on our cam, and again our standard tool library in here exactly matches what's in there. So tool lengths, tool geometries, tool holders, which becomes very important once we start doing multi-axis work and clearances. And you'll probably see that we have quite a few shrink fit holders, and again that's all about just clearances. So a lot of our smaller tools we'll just opt to go with shrink fit, so that we know we're probably going to be using them in a multi-axis operation, and we want them to have as much clearance as possible. So yeah, that's actually been quite a time heavy investment to sort of sit down and work it out, and we're still always developing it, and the same with the 0 point. It takes a lot of investment, but we're seeing quite good rewards from it. Like, we probably pulled our setup time on the milling machine from getting vices on the table and a job in and ready to run. We're probably 25% of what we used to be. So if we were at an hour, we're able to get something in and ready to go in 15 minutes. So, and we find that's given us that competitive edge with being a smaller shop, trying to compete with the larger ones, just trying to be a little bit more efficient about how we get jobs onto machines. The machine in time is going to be machine in time. You're always going to push that as hard as you can, but I feel like there's a lot of time left on the table just in setup and taking things down and putting things back up, and that we try to make that as clean as possible. Again, we've got some tool walls and stuff here that's sort of getting populated as we go along. we've been trying to develop our tool storage system, and we've got some end mill storage here that we've just used some standard plastic boxes, modular boxes from Bunnings, but we try to keep everything as organised as possible. But now we're moving on to a new system, so we're going to a tool management system from Cribwise. That is, I'll show you over here. So we've only just got this, and it is locked at the minute. But basically, tool storage system with all your bins, and basically you allocate your parts to individual bins, so all your different size end mills get their individual pocket, all your turning inserts, your groovers, whatever like that, they all get their individual places, and then it's linked back to this system here where you can pick new parts, load in new inventory, that sort of stuff. I think a lot of bigger companies put these in to sort of manage how much people are taking, or if they're overtaking consumables. For us, we don't have that problem. We're a very small shop. There's 3 of us that run pretty much all the machining side of things, and the office as well. So this is more for us. This is about how to know what we have, be proactive with what consumables we have. So a job comes in that we don't get to the machine and then figure out that we don't have the correct insert there, or that we run out of, we've only got one left and then we're halfway through a job and then we need to wait for stock to come in. So this is basically to try and manage the stock and the consumables that we have, and also they're awesome storage, like to try, and we were just going down the route of Gridfinity and 3D printed modular storage systems and all that sort of stuff, and this is just an off-the-shelf ready to go system, which is pretty awesome. It is 2 different systems, you'll probably see. So this is a Cribwise system and this is a Supply Pro system, but we are integrating the Supply Pro into this system as open stock, so we've basically got the 2 of them running under this system. Yes, and behind you here you'll see our job board, and again this is quite rough and ready. We are just in the process of doing some testing on an ERP system, but we find up to now that this has been really good on tracking how we're doing stuff. So we'll designate certain jobs, so we've got color-coded systems between CNC and manual machining and fabrication if we do have any, and then they'll get schedule cards assigned to each machine. Operator comes in, sees what job is next, moves it down to the in progress column, grabs the job card or the traveller card, moves to the machine, and does the job there. When it comes back, it gets moved over to completed, and that's a trigger for our admin to, or our dispatch really first, to get the job ready for shipping, then triggers it to go and get invoiced and let the customer know. So just trying to develop workflows on how stuff flows through the workshop cleanly and efficiently, and then when we work out all those kinks and bugs, which we probably never will work them all out, but when we get closer to it, then we start looking at maybe moving to a digital system. But yeah, so that's how we track our stuff going through the workshop. So that is basically the floor level of the workshop. As you can see here, there is quite a large mezzanine. This is something that we've installed ourselves, and it's only been in, we only pretty much finished the install maybe 2 weeks, structural install on floor. Obviously we've still got some railings and stuff to do, and there's only temporary guarding up there, but basically we want to get everything that's not day to day on the floor off into storage, on shelves, standardized things have their positions. Like we've got jigs and fixtures here for certain jobs. they should not really be on the floor if they're not being used every day. So the purpose of the mezzanine is kind of twofold. It gives us extra storage up there for stuff that's not day to day. We're actually building a bit of a crib room down the back. The big thing is, as we've grown and machines have got bigger, even with the mill, Harrison and the SL3000, our jobs are getting heavier and bigger. So material handling is becoming a lot more important than it used to be. So the next system to go in here is we're going to swing a gantry underneath. So basically a full length gantry underneath the mezzanine. That'll give us an electric hoist that can move around and load parts in and out of the machines, load fixtures, that sort of stuff. So just trying to make it more optimized and easier to get parts on, easier for the operator. So I'll give that gives us about an extra 80 square meters of mezzanine, and again, we've done everything in-house. So we've been here for quite a few months, but it's we've obviously had to stage the developments to keep work going. So yeah, this one is all done in-house, installed by ourselves. So it's going to be a pretty big asset for us. So this is our coolant dosing system. We've been running this Mixtron. We got it from Live Tools. We've been running for about 2 years, and it's been awesome. It's helped so much. We used to be mixing with buckets and water, and it was just quite cumbersome. But we still need to move this drum around to each machine, run a hose in, dose it, and then take it away. So when you're busy or when the shop is quite full, sometimes that gets a bit harder. It gets put onto the long finger, and then all of a sudden then your tank is low or your coolant concentration is running quite high. So we decided to go with a central dosing system. So this is the central location for the drum. We have mains water plumbed in, isolation valves before and after the coolant drum, and then basically we plumb each of the machines, and each of them has a valve here, and then we can open that valve, and now that's dosing, and you can hear the Mixtron dosing there. So very quickly we can go to each machine and top it up while the machine's running, and it just becomes one of your everyday tasks to do, but it allows you to easily keep on top of that coolant concentration, and it's becoming more and more important as we do more production runs, different materials, more high tolerance stuff. Keeping an eye on that coolant concentration is becoming more important day by day. So a little bit of a probably overkill maybe for a small shop, but we find it's worth the investment to do these things if it means that we're not wasting an hour or 2 hours or having to stop a job or stop a machine to go and get coolant into it. So yeah, we feel it's those things are worthwhile investing in. So I will quickly show you upstairs. That's pretty much the layout of the shop. We've got quite a decent hard stand out the front. We've got 7 car parks, all relatively flat, which is a big improvement from where we were before. And then an extra 80 square meters mezzanine up here. So this is still has a lot of work to be done. Again, temporary handrails and stuff up while we get stuff sorted out. We got electrical install to finish off, crib rooms going down there, some storage here. We do quite a bit of 3D printing now, so we're going to make an area here to house all our 3D printers. And we've got access, we're going to have a sliding gate there for access for to put up pallets and stuff like that. And then here we've got another 2 additional offices. So we've got a design guy working here on design improvements for the shop and all our 3D printing stuff. And then we've got another, this is our temporary 3D printing room where we do all our spindle liners. This will all get moved out onto the mezzanine, and then we've got 2 office spaces up here to run more engineers or admin or whatever, however we need to do. So yes, so that's pretty much it, guys. That's our new workshop and a bit of a tour on where we're at so far. Again, it's constantly developing. We're still trying to keep work going out and operating while making our incremental improvements. So we'll do another one in about 6 months and show the improvements, and we'll do a few more in-depth dives on the machines and sort of like how we run them and how we overcome problems with certain machining jobs and stuff. But thanks very much, and we hope you enjoyed the walkthrough.